Okay, we're rolling. So essentially what he's doing is he is counting the steps in which he is moving away from the base so that we can know the distance between the base and him. That's 20, right?
Yeah.
Okay, so that's essentially 20 steps. And he's gonna try to project his protractor to the very tip of the flagpole. Yep, he's got the angle. What have you got? Supposed to be
50.
50 degrees?
Yeah, 50.
Okay, so it's got the angle from 50 degrees. So now we can easily calculate the height of that pole. Mainly because the angle between the base and him is perpendicular, so it's 90 degrees. So alright, let us calculate. So basically Addison took 20 steps, and inside a shoe, it's been said that the shoe is about 27.5 centimeters. So we can easily count 20 times 27.5, and that makes 550 centimeters. Okay, essentially just what we did, because we are additional math students, we changed the angle to radians because, yeah, why not? So for this matter, we're using the tangent because the tangent is basically the opposite over the adjacent, and because here we are finding the height of the pole and we've got the adjacent. So we're trying to find the opposite from the adjacent, and because of that we are using the tangent. Okay, so Addison's going to input the values. So tangent 5 pi over 18, we're using the radians, over the opposite, which we are trying to find, over the adjacent, which is 5.5 meters. Yeah, so we're moving the 5.5 to the other side, which means that we are multiplying it. So we're just going to input to the calculator and make sure that the mode is in radians, because if it's in degrees, it's going to make your results really messed up. So tangent 5 pi over 18 times 5.5 meters, and we got 6.55. That looks promising because we haven't added his height yet. Remember, we're just trying to find this point from here to the edge of the pole. So yes, the height from here to here is 6.55, corrected to 3 significant figures. Okay, so we're currently in the school clinic to check Addison's height and his eye level, actually, because he measured it from his eye and he's almost as tall as a giraffe. How many is that? 157 point what? What is that? I cannot really see.
0.8.
157.8.
7.
Eh?
7.
Okay, we got 157.7. That's Addison's height. And now we're gonna go back. Actually, can we just do it here? Okay. And we're going to add his height to the calculation to find the height of that pole. Okay, so now we know that the height of the pole is 6.55 meters, and we're gonna add that with Addison's eye level, which is 1.57.
Wait, it's
1.577.
so
yeah.
1.5.
Yeah. And that will be 8.13, corrected to 3 significant figures. And there you go, we found the height of the pole using trigonometry. Okay, so say we build a ladder, and since we don't want to count a lot, we're just going to extend from the eye level all the way down to the floor, so the angle is the same because they are parallel lines. So what we're gonna do is use the sine rule of a over sine A equals to b over sine B. Addison, I need your help because you have better handwriting than me.
Okay.
So, we are going to use the sine rule to find the height, the length of the ladder if we were to build, if we extended the line so the angle is the same.
Okay.
Okay.
How?
You use the sine rule. So, basically we need two sides. So, this and the 90 degrees and the hypotenuse.
What's the hypotenuse?
Hypotenuse, this?
Yeah.
Yeah.
Maksudnya kan kita belum tahu.
No, we can find it.
Yeah.
But we don't want to use the Pythagoras because that's for noobs. We are going to use the sine rule. Okay, so essentially we're going to use A as the height.
So it's 50.
Yeah, that's also 50. So we're going to use the total height of the pole, which is 8.13 over sine. No, we're going to use radians. We're going to use radians.
Oh yeah.
There you go. 5 pi over 18 here because we're pros, right? Ha ha ha. Just kidding.
Okay.
Anyway, we're gonna continue it in the pink paper. So we're gonna use that format, but we're not gonna use C because it's redundant basically. So he's just gonna input the variables over equals to B, which is the unknown value, so just put it as B, over sine pi over 2 because it's 90 degrees. And sine pi over 2 is just 1, so we can ignore that. So B is essentially equals to 8.13 over sine 5 pi over 18, which if we input it to the calculator, that would give us... Okay, make sure it's in radians. Yeah. That has given us 10.6. 3 significant figures. There you go. That's cool. Okay, by the way, if you're thinking of, oh, you should have used the Pythagoras, man. Well, too bad you can't because the length of this to here will be different. It's not 5.5, so you can't use the Pythagoras. That's why we use the sine rule. So basically, in conclusion, what we have calculated, the height of the pole is 8.13 meters. And if we were to build a ladder from the hypotenuse extending to the ground to the tip of the flag, that ladder would be 10.6 meters. Okay, thank you, Mr. Alet, for your time in Global Sevilla. We've been very grateful for it, and we're very sad you're leaving. But what can you do? But yeah, what have you got to say?
Thank you, sir. Okay.
Okay, thanks for watching and